Good day to all out there. Let us continue our lecture series on speech processing. Before getting into the mechanism of speech production and auditory analysis, let's have a quick recap on what is speech processing and its applications. As we know, speech is one of the most intriguing signals that humans work with, and there is specific purpose for speech processing. We need speech processing for better means of communication, to represent speech in form of coding for transmission and reception, and also to analyze speech for automatic recognition of speech signals and to extract unique features from speech, to discover important physiological characteristics of speech. So we need speech processing to get into the details of speech signals. Speech processing has definite applications, including speech verification, speaker verification, speech enhancement, recognition, language translation, and synthesis. In the application of speaker verification, we see that we use speech as one of the biometric signal to access information for getting into a place or to use a gadget. In speech recognition, forensic purposes are solved by recognizing speech into text. It is used in personalized services as well. We can give commands by converting speech to text, and we can use this for home automation as well. Speech enhancement is an important application used in noisy environment to overcome echo, noises, to increase the quality of speech signal, and also to reduce interference. So speech enhancement increases the intelligibility and naturalness of speech. Language translation is yet another application of speech processing in which we make translation from one language to another for coordination between people assembled in a room. Speech synthesis is a widely used application of speech processing which is used for artificially synthesizing speech signals, which will help the people with impairity, impairment and disability. Speech recognition process is predominantly seen as a pattern matching problem. It goes through the following processes. The speech signal is taken into the A to D converter so that we obtain or acquire digital signals which can be used for feature analysis, for bringing out unique features from the speech signal. Then we make a pattern matching between the speech features and the reference features that we already have in our database. By this, we would be able to compare speech features and bring out specific text pertaining to the speech signal which is taken as the input. There are different pattern matching problems in the speech processing. We take the speech recognition, speaker recognition, verification of speakers as also pattern matching problems. We also have advanced pattern matching problems such as the word spotting problem, automatic um, indexing of speech recordings, which would be a real-time problem to solve. And we see that most of our gadgets these days are enabled by speech. We have the voice enabled internet gadgets, we have voice enabled digicams, personal digital assistants, voice assistant cell phones, voice assisted hearing aids for the disabled. So we see that speech has got a lot of applications with respect to the current scenario. And why essentially digital speech processing and not analog speech processing? It's because DSP gives us discrete representation of the speech signals, and we see that digital signals have reliability, flexibility, and we see that accuracy is also obtained in the digital domain. And we would be given the ability to integrate with multimedia, and we can securely transmit and receive speech signals when they are in the digital form. And that is the reason we explore digital speech processing. Yet another application of speech processing includes synthesis of speech, which is the artificial way of generating speech signals by various human machine interactions. It leads to the acquisition of linguistic rules. For sure, we need a DSP processor for analyzing, processing all the textual rules, linguistics, rules like syntax, semantics of a given language, and finally, to bring out speech in its own original analog form, we need the D to A converter. The other applications of speech synthesis include reading of text or email messages by a machine, automatic transactions by just word, and we can call a customer care or a call center and then report the day-to-day things. Handheld devices can be used which are speech enabled to immediately browse through dictionaries, crossword puzzles, phrase books. So gone are those days when we key in commands. Now we can key in commands through our voice. We can make announcement to people regarding stock updates, airline schedules, weather reports, all of these by artificial speech synthesized by machines. And here is another interesting application of speech coding in which we have two important processes, namely the encoding process and the decoding process. On the encoding side, we convert speech into a coded signal by suitable analysis, by finding the redundancy in the speech signal, by applying suitable compression algorithms. Then we get the bit sequence and put it on the channel. And on the decoding side, we get into the decompression part, the de-emphasis part of the speech signal, and then we retrieve back the original continuous speech signal by using the D to A converter. So in speech coding, we foresee compression, we foresee bit sequence, which are the representation of speech. They are widely used as VoIP applications. So in real time, we are able to process speech by compressing speech and transmitting them. We can also add control information for privacy and by encryption, decryption. It can be widely used in military field for preserving the security of the speech by proper authentication. And talking about phonetics and phonology. So now we have learned about what is speech processing, what are the applications of speech processing, speech recognition, speech synthesis, speech coding. All of these are seen as pattern matching problems. So to get into the basics of what is an audio signal, how does the audio or speech signal originate, we have to brush through the concepts of phonetics and phonology. So what is phonology? Phonology is the study of sound patterns, and phonetics is a study of specific speech sounds. So phonetics is different for different languages. Phonology is a generic field where we study about the sound patterns. So both of these studies are very important to understand the characteristics of speech and audio signals. So what is phonetics? It is concerned with speech sounds for a particular language in the world. And we have three types of phonetic analysis: articulatory phonetic analysis, acoustic and auditory phonetic analysis. So what is articulatory phonetics? It is one sub-component or branch of phonetics that includes studies about articulation, how different speech sounds are brought out using different articulators. What are called the other two types of phonetics, one being the acoustic phonetics, which describes about specific information on sound transmission. Another branch is auditory phonetics, which speaks about how we perceive sound. So it all depends upon the listener and also about our inner ear, which is responsible to filter and perceive speech sounds. So when we talk about articulatory phonetics, we are much concerned about the different parts of the speech production system or the mechanism of speech production. We see that the origin of speech is the air from the lungs. It goes up to the trachea, and by the movement of the vocal cords, we see that um, the speech signal, the air is um, converted into pulses and they undergo modulation when they travel through the vocal production tube, and then we see that they come out as speech signals. Here is the schematic view of the human vocal mechanism or the mechanism of speech production. As I said, the quasi-periodic pulses are the result of the airflow through the trachea. These quasi-periodic pulses are then modulated in frequency as they pass through the oral cavity, the mouth cavity, and part of it through the nasal cavity as well. And we have a lot of articulators that are responsible for speech production, namely the jaw, tongue, lips, mouth, and velum. And all of them have their own important contribution towards speech production. So here is another schematic representation of the physiological mechanism of speech production. As already mentioned, air is the source of speech, and the energy depends upon the lung volume, and here we see that the air is converted or split into quasi-periodic pulses, which then go through frequency modulation as they travel through the pharynx cavity, mouth cavity, and the nasal cavity. And there is an important part called as a velum, which separates the nasal cavity from the mouth cavity. So whenever we utter words, velum is closed. When we utter nasal sounds like m, n, all of these nasal sounds are brought out using the nasal cavity. At that time, velum is kept open. So we see that all the associated muscles with the lungs act as a source for the vocal mechanism, and the muscle force pushes air out of the lungs, and the vocal cords, when they are tensed, the airflow causes them to vibrate. And when the vocal cords are relaxed, what happens is the sound or the air travels through constriction in the vocal tract, and thereby some turbulent sounds are also produced. So we classify sounds into voiced sounds and unvoiced sounds. So when the vocal cords are not periodically vibrated, what happens? Unvoiced sounds are produced. Turbulent unvoiced sounds are produced. But when you see on the other side, when vocal cords are vibrating, this will lead to voice sounds. Now, voice sounds are classified based upon the position of the tongue as high, mid, or low vowels. So, we see that front vowels are brought out by bringing the tongue to the front. When the tongue position is taken to the mid position of the hump, mid vowels are produced and back vowels are produced respectively. And the other classification of speech sound include consonant sounds. So when I bring out consonants, the manner of articulation is different. So the place of articulation determines what consonant is produced.